Welcome to Subaru Ecu Flash Training Part 16. In this video, we're going to be taking a look at our hybrid speed density and mass airflow style tuning that's unique to the Carberry ROM. We can run our vehicle in both speed density and mass airflow at the same time, or we can go and bias it different percentages between either airflow registration methods. We have a lot to cover and talk about. In order to successfully implement this, let's jump into our training tutorial so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our MAF and speed density hybrid blending mode in the Carberry ROM. This is going to be a unique feature of the Carberry ROM that allows us to work in both mass airflow based airflow estimation, where we're measuring the airflow, and then speed density, where we're actually estimating the airflow. We've went over these topics individually in separate training tutorials up to this point. This is now going to be combining both of those concepts into one in this Carberry ROM. And again, this is unique to the Carberry ROM. We're not able to do this in the Subaru-based OEM type file. So let's jump in and let's talk about why we might want to do this and how this is going to work exactly, and some details we need to pay attention to if you want to utilize this hybrid SD and MAF blending type mode. So the first thing that I want to talk about is jumping down in here and let's open up our mass airflow calibration curve and our volumetric efficiency table. Let's just quickly discuss these, because they're going to be essentially both into the same video here. The topics are going to be covered because we're dealing with both in terms of what we're doing for air mass determination. So if we're looking here in our fueling speed density, we open up our volumetric efficiency table. We've talked about this. We actually calibrated this in the last two videos. We know that this table now is pretty close. We calibrated using our Subaru closed loop error, and we were going into Megalog Viewer, populating our data, and just making sure that this was okay. Now, as a result of doing that, we watched what the estimated volumetric efficiency channel was showing in our Rom Raider logger, and we know at idle that was around 40 to 50. That's about ideal. That led us to moving into dealing with our injector latency at idle to get that sorted out. And then all the other part throttle tuning as we're driving through the individual cell points in the table, we utilized that closed loop error to sort it out and making our percentage changes and updates. Then we moved into open loop tuning using our AFR error channel and our Megalog Viewer HD and a histogram to be able to populate our positive manifold pressure or boost pressure ranges here for our volumetric efficiency table. So now that the table has been sorted out, we know that speed density has been fully tuned off of the wastegate actuator level. We can now take a look at implementing a mass airflow hybrid speed density mode and what that's going to actually mean here. So what I want to do is open up our fueling mass airflow MAF sensor scaling, and let's quickly go here to edit, and let's go in here to our graph, actually into view, into graph. So what we're seeing here is that we know the difference, and we've talked about this extensively. The VE table represents the estimation of airflow. The mass airflow is the measurement of airflow. The mass airflow sensor is still present on this vehicle, so if you were going full speed density, you couldn't use MAF speed density hybrid mode. In this case, I'm utilizing the stock MAP sensor. We're utilizing the stock MAF sensor in housing assembly, and we can combine the best of both in terms of airflow registration and fuel and spark timing delivery. Now, in this speed density Carberry based ROM, we know that the airflow determination here in terms of mass airflow can either be turned off or turned on. We can find that under our SD MAF blend mode. Now, in this case, right now it's set to SD MAF blend, speed density MAF blend. We can go here, if we click on this and click our right close bracket key, we can make this fully speed density where we don't look at the mass airflow. We can completely remove the mass airflow altogether and just utilize the MAP sensor in terms of our load registration and actually doing all of our tuning for spark timing and other functions. We can also go in here and actually change this to mass airflow, where we utilize the mass airflow for fuel calculations in terms of our air and fuel calculations, but we'll find the spark timing is still referencing off of our MAP pressure sensor. Now in this mode here, if we toggle it one more time, SD MAF blend, we'll find that we can utilize either the speed density or the mass airflow sensor for normal idle and part throttle driving. Then we can switch over to the either situation, speed density or mass airflow. The common way to do this is utilize mass airflow registration for idle and part throttle driving. As we transition into boost, we can then utilize our speed density operation, because we can easily max out our mass airflow sensor if we don't have it in a large MAF housing size. If we run too large of a MAF housing, much above 3 inch, we lose resolution and we can lose drivability. So this is allowing me to utilize the stock MAF housing, utilizing essentially the stock MAF curve to simplify the calibration process for fuel and airflow delivery, for fuel delivery and airflow registration using my MAF curve. And then when we get into boost, we can simply switch right over to the MAP sensor, ignore the MAF sensor, and then run it off of what we've already calibrated here. This is an ingenious way to go about calibrating and tuning your Subaru. Essentially gives you the best of both worlds. We can have the simplified tuning process to run our engine at idle and part throttle off of the MAF, and then switch it over to speed density where it doesn't have that potential restriction where the MAF could start to cap out, or we have to go and change the physical MAF housing size, which can cause resolution and drivability problems. Now, if I'm going to be using this, I would prefer to use this on a Subaru that has a recirculated blow-off valve, because when we lift throttle, it loses.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.